Okay, so for number three, I remember that we got this wrong on Tuesday.
Yeah, we were confused between p hat and p.
Yeah. So p hat isn't that the true population proportion? And p is just the sample size.
Let me get to the questions.
No, I think that you're flipped there.
See, that's what I thought too, but I remember on Tuesday that I thought it was flipped and I got it wrong.
Yeah, the way I remember it when I read it, so like x, it would be four. We have x and x bar. X was the true mean, right? And then x bar was the sample. So, so I think that it's the same here, where just p is going to be your population, and then p hat, anything with the symbol above is referring to your sample.
Okay, so you're saying p hat is the sample size?
Yes.
Okay.
Kind of runs parallel with the sample mean and whatnot.
Okay, that makes sense. Sweet. Do you have that pulled up yet, Jason?
Yeah, I've got it now.
Okay.
All right. So we're saying that the symbol, the true proportion is p hat.
No, p.
It's
Yeah,
not.
p.
Okay. Yeah. All right. We had that one wrong earlier.
Yeah, from Tuesday.
Okay, question four. For question 4 and 5, use population size 100, p of 0.25, and p hat of 0.1. The requirements for constructing a confidence interval satisfied? I don't know. What were the requirements?
Let me look. Isn't it just to have those three variables, like your sample size, the p hat, and the p? I'm pretty sure.
Xn, and p. Right.
Yeah, I think it's true, because all you need is to find the confidence interval is just those three variables that it gives us.
Yeah,
Yep.
'cause
I'm in the reading and I just found it. It's true.
Sweet. Number 5, the requirements for conducing a hypothesis test are satisfied. Hypothesis test.
Way back.
When you have a confidence interval, hypothesis. Test.
Oh, I don't. It doesn't appear to be in the reading.
Yeah.
This week.
I'm just gonna say true, because I'm pretty sure when you have a confidence interval that you can also conduct a hypothesis test.
Okay. Number 6.
I'm not finding it.
So you're just saying that we can always do a null hypothesis. Right.
Yeah. Yeah, I think it's true. All right, who's got number 6?
Okay, I'll do it. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use this information for 6 through 8. Find p hat, the point estimate of the proportion of the first-degree murder defendants who are found guilty in this state. 3 decimals.
Okay.
So
If I remember correctly, to find p hat, we do.
this is just like last week, right? I mean Tuesday. Same question.
Mm-hmm. Isn't it just 45 divided by 60?
That's
Yeah.
0.75.
Yeah.
That's
You have to have 3 decimals.
Yeah. So 0.750.
so using that p hat, we have to create a 95% confidence interval. So going back to the reading again.
Yeah.
There's so many formulas. It's hard to keep them all straight.
Yeah.
Okay, so it's confidence interval, right? Yeah, confidence interval. Probability. Oh, it's on the next chapter. Number 17. There we go. Okay, so to find a confidence interval, we have to find the
Z score.
z-score, and then that's all we need.
Yep. Then we've got N.
How do we find z-score using the p-hat? Let's try and find that now.
Remember.
Z-score.
Oh. 95% is 1.9.
Oh my gosh. Why do I always forget that?
We know this.
Yeah, it's given to us, right? That number's
Yeah,
given.
it's
We just
1.96.
we add it and subtract it from
I'm just going to run this in an Excel.
7. So we take it from 0.75 and we subtract it, and then we add it, and that should give us both, right?
Yes.
6. So it's the square root of pi hat, which is 0.75, then parenthesis 1 minus p hat, 0.75, divided by n. What was n? Do you do 60 or the 45? Probably 60.
Sorry, hold on. The n was 60, and then the 45 isn't anything. That's just that's how you find your p hat. So n is 60.
Okay. 0.75. Oh crap. Clicked my memory button at the wrong moment. I gotta start over.
Calculator.
Okay. So my answer's not on. I'm gonna have to
Dang
start.
it. All right, let me try it one more time then.
Yeah, we need. I'm gonna do it on Excel this time. Make it so it's for sure. Equals.
Okay.
Okay. Excel gave me one that's correct.
What'd you get?
I got 0.064043 whatever. So 0.640. So it would be B for the lower bound.
That's what I got.
And that matches the higher.
And then I already ran the numbers for when you increase the sample size to 80, and that would cause your confidence interval to decrease.
Okay.
I thought it was increase, but it's actually decrease. Because the higher the sample size, the smaller confidence interval you're going to have.
All right.
Yeah.
Nice.
Okay. We're done?
I can read it. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P is equal to 1/2. What's the smallest N can be? Both requirements, and both requirements still be met. So we have to. Do we just convert P to 0.5? We're not going to leave it at 1/2. So.
Yeah.
All right. Didn't we? There
What
was
was that
something.
equation to find N?
There was something earlier in the other homework that it had to be 40.
Wasn't that number 30?
No. Is it from the individual preparation on Tuesday?
I'm not sure. So I was just trying to remember how to find N. I found this. I don't know if this is right. Is this the equation to find N?
Let me look at your screen.
Yeah. There was a more simple one, wasn't there?
Yeah, and then you simplifies it, or what's it called? Not simplifies. That's not even a word.
Simplify.
Simplify. I'm tired. Then it becomes this right here.
Oh. What does M stand for again? I can't remember.
N is the sample size. That's what we're trying to find. Oh, M. M is a confidence level.
Oh.
Oh, I'm sorry. No, it's your desired margin of error. Do we have a desired margin of error? No.
Oh, it tells us it's P. To be 1/2.
Oh.
We're using a previous question.
Two requirements. What are these two requirements must be met? What is it saying? I think I remember. 1 second. Find it. Maybe not.
I'm not finding it, but I'll keep looking.
Oh, isn't the n parenthesis 1 minus p hat?
And parentheses 1 minus p hat. Yeah, it might be.
What's our n?
N is, I don't know if it's still gonna be 60 or 80 now. Let's go with 60.
60. Well, that puts you at 30. Plus under or less than 30. Greater than. I'm wrong.
I don't remember this.
Six through 8.
So there's not a way we can go back to the. Anyway, let me see if I can launch it again. Okay, so from if I'm looking at the quiz that we had on Tuesday, and it says that p is equal to 1/4, and what's the smallest n that can be to satisfy both requirements is 40. So that's what we put for number 7 on Tuesday. So this is a similar question.
What was p on that question? That you're referring to?
It's 1/4.
Oh, then it would be 20. Because 1/2 is twice as large, and that means that the sample size would be twice as small.
This is true.
And then.
So you're saying as the numbers get smaller, the n gets larger.
Yes.
Because, okay.
Yeah, because for 1/10 it would be 100. It's basically you look at the denominator and you add a 0.
I'm back. I got lost somehow.
Okay,
what did you say when I heard something about 1/10? I didn't hear.
So for 1/10 it would be 100, because I guess the easiest way for me to look at it, since that was good that you went back and looked at that, because so 1/4 is 40, so you just you look at the denominator and add a 0, and that's your sample size. Because for 1/2 it'd be 20, and then for 1/10 it'd be 100.
Just like 1/4 was 40. Okay.
Yep. Okay. So for these next questions, we're going to be using all the same data. It says for the water quality study and the reading, about 60% of the macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significant level of 0.05 with the following hypothesis of 0.6, and alternative is less than 0.6. Then we have the sample size of 80 and x equals 38. The conditions for conducting the hypothesis test are satisfied. Well, I would say true, just because with number 4 we said that was true as well.
Yeah, conditions are met.
Yeah. And then for number 12, we have to find p hat. So again,
Go back to that calculation again.
well, it's 60% of your sample size, which is 80. So whatever 60% of 80 is, which is, let's see, half is 40. So 10% more than 40, so 44. 44 divided by 80.
Let's take.
Wait,
Oh, sorry, 48 divided by 80.
38?
48.
Where are you getting 48?
So it said
X is
60%.
38, right?
yeah, x is 38. It's 38 divided by 80. That's your answer.
Oh, sorry, guys.
60%.
I was looking at the 60%, yeah. I forgot that they gave us the sample size. Or
So 0.475
Yep.
is 60% of, well, or 38 divided by 80.
yeah, I didn't even see the 38. That was my bad. And then to find z, so we're conducting a 95% confidence interval. So the z is going to be 1.96. And then we have to find it.
Is it 95%? I'm not seeing where it says that.
Find
'Cause
the
there's-
test statistic. That's all it says.
Is it a 95% because the level of significance is 0.05?
Yeah, 0.5. Yeah, makes sense.
No, that's
Alpha is-
not related.
Oh,
is
it's
it
not?
alpha?
Gosh,
No.
I'm getting everything switched up now.
95%, that's your, that
Confidence
rule
interval.
of 60, 95, 99.7.
Yeah, confidence interval. Sorry.
So on this one, I think that we can figure for z. So that equation that didn't you have an equation for that?
Yeah, I'm getting back to it. Sorry, I'll get it up here in a sec.
Because we needed the confidence interval for m. M was the denominator or something.
Yeah, I got that mixed up. I must be really tired or something. I'm just like throwing things out there that are completely wrong. Okay, so I'm pulling up the reading.
Yeah, I've got it here now. Well, mine's for n. But we could figure for n and just have z. I don't know.
Okay, so to find z, you do the p hat minus the p divided by your standard deviation.
Do we have?
How we? Yeah.
Yeah, I'll just screen share again.
Let me look.
Can you guys see that?
Yeah.
Sweet. So yeah, that's how I find it. So what's our p hat again?
P hat is
0.475.
yeah.
And then what's our p?
38. Or
That's X, right? Or,
I don't know if we know p. Oh, we do. The original hypothesis says it's
Oh,
0.6.
0.6. Yeah. So minus 0.6. That's going to be our numerator. So the numerator is negative 0.125. And then our standard deviation, which is going to be using p, not p hat. So 0.6 times by 0.4 divided by, how big is our n?
80.
80.
yeah, that's 80, yeah.
And then square root of that. Okay. So
What do you
number
get?
plus. I got 0.054772, like a big number.
Okay.
Save that number, and then 0.475 minus 0.6 divided by memory recall. I got negative 2.282.
Okay. Negative 2.282.
Yes. And then p-value. Find the p-value.
So that's using the applet, right?
Yes. And I'm plugging it in right now.
Okay. I was pulling it up, but I'm not going to.
So negative 2.282. And it's our alternative hypothesis is everything less than. So
Yeah,
it's just the one side to the left. So the area is 0.001. I'm sorry, 0.011.
Okay.
0.011.
What is the decision? It is less than, so we reject. Is our level of significance 0.05?
Yep. Reject the null hypothesis. Then number 16, which of the following best summarizes the conclusion of this test? There is sufficient evidence to conclude that water. It's isn't it? There's sufficient evidence to conclude that the water quality in the area has decreased.
I'm rereading.
I don't understand.
This.
Well,
Yeah.
Jason, from what we found using our z-score and the p-value, it is less than the level of significance. So we rejected the null hypothesis.
Okay. All right.
And yeah, our alternative says that it's less than 0.6.
Yep.
Okay, it is.
So there's sufficient because we rejected. If there's insufficient, we would fail to reject.
Yep. Sweet.
Okay.
Let's see how we did. Oh my goodness.
Oh my goodness, 100%.
There you have it.
Rose.
we needed that from getting the C last time.
Yeah.
Gosh.
Okay, thanks. That was pretty quick.
And then on the group,
Oh yeah.
I guess we can just kind of keep in contact using the email. I think Josh Fulmer, he said in his email that he's going to take care of the design the study. I don't know if we need to do anything else. I think he actually made a Google Doc. Yeah, it is a Google Doc. So, no, it's just a Word document. We should just make a Google Doc and work on it together. I'm going to add Josh to the group chat, and then we can kind of just work on it to tomorrow and Saturday, so we can get it all done.
Does it have to be approved?
Yeah, so just this Saturday, we have to get, what is it that's due this Saturday?
Design the study. So
yeah, it's just design the study.
he said he already did that, and there's going to be all these different parts of it, just like in our reading, we have the same bullet points. And then we have collect the data, describe the data, make inference, then have a PowerPoint evaluate presentation.
Okay.
So we'll just have to break those up. We can talk about it this Saturday when we submit that.
Sweet.
All right.
Sounds good. Good job, Nate.
Okay, have a good night.
See you guys.
Thanks. Bye.